So this question is a geometric sequence question. Find the common ratio. Now, whilst it looks unpleasant because we've got natural logs here, you've got to remember that the rules are still the same. To find the common ratio, it would be u2 divided by u1, or u3 divided by u2, so on and so forth. So I'm going to focus on u2 divided by u1, so that's ln x to the 8 divided by ln x to the 16. We now have to remember our laws of logs. If we have logged with something to the power, that power can come in front. We then are able to cross out the ln x. So our common ratio is 1/2. Solve. K is 1. This, hopefully you remember, means sum. This symbol here is an infinity symbol. So we are finding the sum to infinity of this function and saying that it's equal to 64. So we are going to go back to this. Should have just copied it from the other one. Oh well. Okay, so we're finding sum to infinity. Well, first of all, we need to establish what this function is. Now, sorry, not what this function, the sequence is. The fact that they've got this thing up here is going to be connected as part A and B. But I appreciate some of you may not have noticed that. They've got here 2 to the power 5 minus k. So that would mean that u1 would be 2 to the power 5 minus 1 ln x. So that would be 2 to the power 4, which is 16 ln x. u2 would be 2 to the power 5 minus 2 ln x, which would be 2 to the power 3 ln x, which is 8 ln x. At this point, I would hope that you think, aha, these are the same values, therefore we're talking about the same sequence as we had up here. This value could come in front, 16 ln x, 8 ln x, 4 ln x. So we're using this, essentially this sequence. Okay, so what they're saying is that the sum to infinity is equal to 64, and they want us to solve it, which means to find the value of x. So the sum of an infinite geometric sequence is given by this formula. So sum to infinity is u1, which we know was 16 ln x, divided by 1 subtract a half. Excuse me. So 16 ln x divided by 1/2. If you're dividing something by a half, it's the same as multiplying by 2. So we have 32 ln x. And that value is equal to, what's it, 64? 64. So we're trying to find ln x, so we're going to do 64 divided by 32. So that's 2 equals ln x. Now, from this statement here, we're trying to find an expression, we're trying to solve, so we're trying to find x on its own. So we go back to here, and remember, again, our laws of logs. This time we're going to focus on this thing here. We have a log statement here. It's not really written just like this, but that's because we've got ln. So secretly we're writing log base e here. So if we were to then use this, or connect our values here, and to rewrite it like this, we would have e to the power of 2 equals x. And there we've solved it. We would leave it as e squared. It's a non-calc paper, you did not expect you to do any more. Right, the equation blah blah has two distinct real roots. If we know we're talking about the distinct real roots, we remember we're talking about the discriminant. In other words, b squared minus 4ac. We know that b, well, let's actually identify all the letters. A, looking at this quadratic equation, a has the value of 1, b has the value of k plus 2, and c has the value of 2k. You've got to remember it's just the coefficients of the x squared, the x and the constant, not anything else. Some of you are writing x squared and getting confused there. So b squared minus 4ac, our expression would look like this. Note my brackets are super important. Okay, so we've now got did that for multiplied by 1 multiplied by 2k in my head. Good like that. So I've got k squared minus 4k plus 4. So that's the expression for my discriminant. Well, if I've got two distinct real roots, it means that that discriminant has to be greater than 0. Okay, so if it's two distinct real roots, it has to be greater than 0. So now I'm going to factorize. I know that it's negative 2, negative 2. So in other words, k okay, so if in order for this to happen, we know that k cannot equal 2, because that would give us a value of it equal to 0, which means that k can be any real number, but it cannot equal